follow along with this tutorial, you'll need a UV grid node. If you don't have one, have a look at episode 1 of this series. You'll also need an image texture atlas of the letters or glyphs or figures that you want to use for the animation. If you already have one and it's correctly laid out in a rectangular grid fashion similar to this, then you're ready to go. If you don't, I'll show you how I put together this atlas here. I did it in Blender with a font that I downloaded from dafont.com. I did a search for Matrix. I got this selection. I'll scroll down a little bit, and this is the font I chose. It's called Matrix Code NFI by Norfolk Incredible Font Design. This is not the actual font used in the production of the movies or the advertising campaigns. I don't think that font was ever actually officially released. This is a representation of the font that appears in the movies. In an actual fact, I think it is heavily inspired by katakana figures, but it will absolutely work for our purposes. This page shows us the available characters that we have. We can see that all the uppercase letters will appear as standard letters, so that's not going to be useful. All of the lowercase letters, on the other hand, will be useful. The numbers will not. They seem to be flipped. Some are flipped, some are not. I'm not sure the logic behind that. But here we have more characters available, mathematical characters, dollar signs, etc., etc. For a grand total of 56 characters, which we can lay out in an 8x7 grid. So let's see how I did that. This string right here represents all the characters available as part of the Matrix font that we downloaded. I'll include this string in the description of the video to save you having to copy this all out. You can copy and paste it. Now I'm going to duplicate this object and drag it down a little bit. Now come over to the Properties panel, to the Font tab, and I'm going to change the font to my Matrix Code NFI. And there we go, we've got our glyphs. Now, as I said, there are 56 characters here. So I'm going to arrange it in an 8x7 grid, 8 horizontally. So I'll skip every 8 characters and then move the line down. And that makes things a little bit easier because now we need to arrange these characters into a tidy grid, a rectangular grid. Let's begin by changing the alignment. I'm going to change to bottom baseline. Move this down one more unit. There we go. Now I can align them more or less, paying attention to the left edge here, and align them vertically inside the cells of the grid here. Now I can come over to character spacing and space them out so that each character more or less gets its own cell, something like that. That'll work. Now I'm going to convert this text object into a mesh. And now I'm going to go into edit mode and select all the pieces and separate by loose parts. Now I'm going to go through the pieces and align each individual character into the center of its corresponding cell. So I'll speed this part of the video up and see you in a few minutes. And there we go, all my glyphs in a tidy grid. Now I want to make this grid a square grid because textures like to be square very simply. So I will add a plane, drop it in the center more or less of my text grid, and now scale it up to fit. That should work. Now I'll subdivide the plane. Remember the grid was 8x7, so I'll subdivide horizontally 7 times and vertically 6 times. Now then select everything and delete only faces. Let's select the top left vertex of this grid and align the cursor there. I'll select my grid and scale it horizontally with the 3D cursor as my origin point. To make a square, here we have 1, 2, 3, 4, 5, 6, 7 cells. And I know my grid is 7 tall, so this is a square. I'll select all my glyphs and deselect the grid. Make sure the active object is one of the glyphs. And now I'll set the origin of each individual object to geometry. Set origin, origin to geometry. Now make sure I'm still using the 3D cursor as my origin point and that only locations is turned on. And I'll scale them until they fit in their squares. Right about there. Perfect. Now, origin to the center of the grid, and I'll create a camera. I'll move it up by 1, just as a force of habit. Now I'll set the camera to orthographic with a scale of 7. Let's have a quick look at the shading. I'll select all the glyphs again, deselect the grid, come over to the Materials tab, and we'll give the active glyph here a new material. I'm going to set the surface to emission with a color of bright white, strength of 1. Now I'll press Ctrl and L and make links to materials. This sets the material from the active object to all the selected objects. Now I can preview and see that I get my black background and my white glyphs. I'll now render that out and save it as an image texture atlas for use in Blender. Here's our UV grid node. We'll give it a UV map. And let's bring in our texture atlas. Open. Browse to where you saved your texture atlas. And let's have a look at the original atlas. Preview it with an emission shader. There we go. Now then, if you remember from previous lessons how we treat an atlas, we use vector math nodes. The first one we'll set to multiply, the x component of the input vector being 1 divided by the horizontal number of cells. That's 1 divided by 8. And the vertical 1 divided by 7. We get cell 1 of our atlas drawn at the size dictated by the UV grid node. We're making progress. Let's duplicate this node and change the operation to snap. We'll plug the random color from the UV grid into the top and duplicate this node yet again and set the operation to add, and now plug the result of the snap node into the bottom. And we're getting randomly selected glyphs. To get rid of these borders appearing around the cells, set the texture interpolation mode to closest. Now then, let's introduce some animation because we want these glyphs to change one by one over time. And we can make them change with an add node dropped here onto the random color. You'll see that if I reset these values, the glyphs change, and I can cycle through them by increasing both the X and the Y components. So let's take advantage of that. We can plug a time variable into one of the channels of this vector, and we can get a time variable in our shader with a value node, an input value node, and into the input field I'm going to type hash frame, and that now gives me a numerical representation of the current frame of my blend file. I'm going to take that result and divide it by the frame rate of my blend file, which is 30 FPS right here. And this node now gives me the time in seconds. You'll see if I preview it, if I press play, this will very quickly become white at precisely 1 second or 30 frames. And from then on, we shouldn't see any further change. There it goes. So there you go. This is time in seconds. And we can now very simply take that and add that to our random color vector here by combining it into a vector. I'll plug that into the X channel. And the result of this combine XYZ node goes to the add vector. And now when I play, we're cycling through our glyphs automatically, but entirely too quickly. That's very easily changed. with a math node set to multiply by something quite small, 0.01. Let's see how that goes. Drop it onto the noodle. That looks much better. Let's go for 0.02. Excellent. So now we have our grid of glyphs. And to create the rain effect, what we're going to do is fade these glyphs in and out, and we'll do that with a separate XYZ node, which will split apart the stepped output of the UV grid. Let's have a look at the outputs. We've got our now familiar columns. Let's use the Y channel. So we've got our vertical increment going on, which can definitely prove useful to us right now. Let me, before I forget, separate the color output of the texture, just so now I'm using simple values. And if I multiply this value result by the Y channel of my stepped output, you'll see I'm getting a fading gradient to the glyphs. We can definitely do some more with this by, for example, adding our time variable. Let's see what happens. Predictably, the glyphs get brighter. We can make the time loop by using a math node, and we're going to use the modulo function. I'll set it to 1 for now, and with a modulo of 1, meaning a loop of 1, we shouldn't see any difference. But obviously there is a loop as opposed to a steady increment. I can increase this size to get a longer loop. Looking good. But now we need to introduce a lot of random to this animation. Clearly all of the columns fading at the same time will not work. So let's use the X output of our stepped vector output, and we're going to use it to drive a white noise texture set to 1 dimension. I will split apart its color output to use several random channels. The first random operation I'm going to do is to change this variable right here per column. So let's drop in a value mix node, which will take the green channel into the factor. Now I can set a minimum of 1 and, for example, a maximum of 2. Let's see what it looks like. Play. And we're already getting some random going on. Let's take the random a little further still with another value mix node, and this time I'll use the blue output. And with this new random channel, I'm going to multiply the time variable. So some columns will actually fall faster or slower than others. Let's drop in the math node onto the time noodle, set it to multiply, and into the bottom we plug the result of the value mix node. Now let's give it a minimum of, for example, 0.3 and a maximum of 1. Let's see what we've got. Looking pretty good, I think you'll agree. Let's do a little more over here. We're actually getting blown out values here because we have exceeded 1 in almost all cases in almost all of the columns. So we can normalize the result of the modulo node by dividing the result by the same value we fed to the bottom input. Very simply like that. Now the fading factor, the fading value of all of the glyphs ranges from 0 to 1. With our newly normalized gradient, we can flip the gradient very easily with a math node set to subtract, and we'll subtract the result of the gradient from 1. We're getting much closer to the result we want right here. Now we can change the fall off, by which I mean the dimming of the glyphs, how much time the glyphs spend in the darkness essentially. With a math node set to power, I'll use an exponent of 1 for now so we don't see any change. And now I can increase the exponent to dim the glyphs much more quickly. Let's turn on clamp so we don't exceed 0 or 1. We'll reduce the size of the grid overall to something quite a bit smaller, 0.02. I think you'll find that is not a million miles away from the effect we want, but we're missing that matrix green, aren't we? Let's do that. We'll come over here to the final result, the final multiply node. We'll drop in a color ramp node. Move it over here a little bit. Click the plus symbol to add another handle. And this handle will set to a bluey green color, somewhere around there. Turn the brightness up to maximum. Hit play. That is looking pretty darn good. But because we're playing with UV grid, we're going to go one step further. And we're going to use a UV grid on our UV grid with a very small tile size. For example, 0.001. I'll drop that onto the UV grid's UV map. And that won't do, so I'll swap the noodle into the stepped output. And you can see what I'm going for here. And we've got a pixelated effect, but we can make that look a lot better. I'm going to move it over to the left a little bit because I need some space. I'll drop in a UV distance node, which you should have if you followed or if you've seen the last video, the one before this one. If you don't have the UV distance node, you can use the built-in gradient texture set to spherical. I'm going to proceed with my UV distance. Let's preview it so you can see what I've got. There are my radial gradients with 0 at the center. So I'll invert the gradient with a math node. Set to subtract. There we go. And now I will harden the gradient quite a bit with a divide node. Turn clamp on. And now you can control the size of the edges of these disks with this value for a little fall off and to help with the glowing effect essentially. Now we'll come right over here and I'm going to multiply the output of the glyphs texture by this result here with a math node, set to multiply, drop it onto the texture result and plug the result of the multiply node into the bottom. Now let's have a look at the result of our color ramp node. Things have gone wrong, or have they? Let's zoom out. Ooh, there we go. Let's come over to our UV grid nodes a second. Let's choose this one with the very small pixel sizes. Turn on offset correct and introduce an offset of 0.5. Looking very nice. And one final feature to introduce, we can come over here to the modulo and divide nodes. I'm going to press Ctrl Shift and D to duplicate those nodes and maintain incoming connections. I'm going to swap the modulo operation to snap. And what this gives us is a type of mask, an increasing number for every repetition of the falling letters. You can see it better if I add temporarily a white noise node, one dimensional. You can see that the colors are changing for every repetition, for every loop of the animation, let's say, and it is always column dependent. There's no real need for random colors. All we have to do is to multiply this result by the value we have input into the Y components of these vectors here, the snap and the multiply. I'll copy and paste into my multiply, and the result of this multiply goes into the Y component of the additional vector offset right here. Now let's have a look at that. And now you can see if I zoom in, that the glyphs change as the loop repeats. Take note of that glyph there with the cross shape and watch for when it flashes white. The glyph has officially changed and each repetition of the loop is now fresh. And there you go. That's how you make the matrix text rain effect in Blender. Let's extend it just before I go. Let's come to the default view for a bigger window. I'm going to add an array modifier. Actually, let me see a preview. Add the array modifier and turn the UV's U offset up to 1. Pretty darn good. And that'll do it for this video. This was a little shorter perhaps than previous videos, but I hope you found it useful and I hope you liked it. If you did, please drop a like, and if you would like to see more video content like this, please consider subscribing to the channel. Thank you for watching, and I hope to see you in the next one. Take it easy.